Hello, in this video I will explain our work for project 2 which involved the protocols. Here we have a stop and wait protocol. Um, I already ran this Jupyter notebook and we will see how it works. So we start out by creating these loops. We're starting with the application layer for Alice. We have the transmitter and the receiver loop. That is the upper layer. That layer will communicate with a lower layer, which is the data link layer. Here, the transmitter loop and our receiver loop are created for Alice, and this layer communicates with an even lower layer, which is the physical layer. And we start a transmitter receiver loop for Alice too. In this model, the application layer for Alice will never communicate or transfer information to the application layer for Bob. Instead, in this model or in this protocol, the message will go down layers all the way to the physical layer, and the physical layer will communicate with the physical layer for Bob. So here we also create these loops for Bob, for the application layer, the data link layer, and the physical layer. And we are starting this finite state machines and timers, which they will define the states on what to do, whether the message is received or the packet is lost, and the timer will be useful for when a message is not transmitted on a certain time, when the confirmation is not received on a certain time, then the message is sent again. So here the application layer sends 20 messages to Bob. Okay, so then this message, each message is put in a queue. So the first message on the queue, the data link layer will take it, and will go, the full state machine will go to the next state, which is to send. Okay, the data link will send that message, this message, to the physical layer, and the physical layer will transmit that message to Bob, to the receiver end of the physical layer of Bob. Then the data link layer of Bob receives that message, and the state machine of the data link of Bob changes to the received state. Okay, so it says here received, and it sends the confirmation message to the physical layer of Alice. Here it is. It receives a 10, so it received the message. Okay, and now Alice knows, the data link knows that the message was received. The state machine goes to the receives the event type. It was in the waiting for ACK state, so now it can go to the send state again. So the data link sends another message, the next message on the queue. Okay, so this here we see that the ACK does not match the sequence. This happens because it was expecting another number. It was expecting another number, another confirmation, and it did not receive that. Okay. We will look for a packet loss. Okay. When we lose the packet, the protocol here, I pressed the Bob to Alice button, and the application layer put all these messages on the queue, but on the part of the Alice model, this packet loss goes all down to here. Okay. Because of the packet loss, this will resend the message to Bob. Okay, it will resend the message. Here it is. It resends the frame to Bob. Okay. So this code also has the changes. If so there's a random packet loss of 15%, and there's a random duplication of 5%, and on the receiver end there is a random delay from 0 to 3 seconds. Okay. On the experiment part, here we have the design of the measurement layer entity, which is different from the application layer in that the measurement layer is designed to measure the loss rate, the average delay, and duplication rate. Okay, so here is that constructor. We have the name and the lower layer, and then the results, the queue, measurements, and creating the buttons for the input. Okay, and then the event when a button is clicked. This is the design for the RX function, the receiver function, which will receive on the other end the measurement layer entity. Okay, and it will stop the time for the measurements, and this is the output, the method to generate measurement outputs. So it takes the numbers that are saved in the measurement entity, and it calculates the loss rate, duplication rate, and average delay, and outputs those results. Okay, so in general, we can see that adding a data link layer adds reliability to the protocol, but it costs more delay, more time. Okay, so thank you for your attention.
Hello, Professor. This is the recording for section 5 of our second report. I'm responsible for doing the IPERF section, and so I'll be showing exactly what I did for the tests. I'm hoping that for the public server test that we did, they work, because I had some issues finding one that was available at the time, and after working on it multiple times, I finally got one to work. So hopefully it works in this quick little demo. But over here, I'm just running the public or the local TCP test. And so yeah, here it's running bit by bit. I want to see if it's similar to what I ended up getting on the paper, because this one's a live demonstration after we've already done it on the paper. Yeah, well, this time it actually got different values, because on my paper the transfer value is 64.3 gigabytes, but now it's 21.3, and the bit rate's also slower. So I don't know if it has to do with just traffic in general, or because I could be recording a video. I don't know if that affects it all that much. And then even on this side, yeah, the transfer and bit rate are different. But that was the TCP test. And then for the local UDP test, I would be doing, let me see, iprf3.exe. dash C 127.0.0.1 dash U dash B, and then 100. Double checking. Yeah, because on the paper we had 100, 1G, and 10G. So this is the test on 100 mega. Very simple. And then, I should have just copy pasted IPR3.exe-c 127.0.0.1-u-b, and then 1G, and then let me hold on to that for when we do the 10 gigabyte one. Yep, here we go. And then our last one will be 10G instead. Yeah. And so those are our 3 tests that we did for at least the local ones. Then on the public one, I only really had just this. Let's clear it out. And at least for the TCP ones, I ended up using speed test servers. So I'm hoping that when we do it again, it works. Servius.net and then -p and then 5002-T15. And then I'll save this real quick. Yeah, that sucks. Let me see if there's a different server at the moment that I can use instead of. Let's see. There's this French one that I can test, so maybe we have a better chance on that one. Speed test dot or speed test dot milkywan.fr. And then this one doesn't have anything port-wise. -T15. Let's see. I'm doing a quick voiceover for this section as my microphone cut out, but basically I was doing multiple different TCP tests on public servers. As you can see, I finally ended up finding this one to work, and also after a bit of searching for UDP ones, which is what I'm currently doing off screen on my second monitor at this point, I'm searching up for other servers to test on UDP, and so yeah, I think there's gonna be about like 5 or 6 before I finally get around to getting one that does work. So let's see. Yeah, this is the 3rd one. If I remember correctly, I think it's eventually the Moji or Ping one, the ping.online.net one that works. But we ended up going through a whole bunch of different ones that did and didn't work. Eventually, hopefully towards the end. The sad part about the public ones was either not being able to connect to them or straight up just not having them work. Them being busy and running a test at the time. Tried a whole bunch of French ones, a whole I think there was one from the Netherlands, one from Ukraine, or a couple from Ukraine, one from the Americas, and sometimes it would just outright either say, error, the server is busy running a test, or error, unable to connect the server. So this would even happen on the paper. It took me a couple of tries just repeating them over and over before I found one that I could do. And I guess the correct option would just be continuously trying one that I know I'm connected to but is busy running a test at the moment, because then that eventually means it will open up. But me being a student, I'm impatient. But yeah, I'm recording this voiceover because sadly my microphone wasn't working. And let's see. Yeah, this one's one that didn't connect. And then, yeah, I canceled it. And I think here, I finally got it to work on 10 mega. And then after it finishes, I run it the same, but on 100. And that's basically what I did for the IPRF version of this report. So thank you for watching. Hopefully you're having a nice morning or afternoon or night or whenever you're creating this. Thank you.